All right. Good morning, students. So this video takes us through a new topic, which is the parabola. And yes, as much as it is a new topic, it's very much similar to what we have been doing for the past, I must say, 6 to 7 classes or sessions that we would have met, right? So it's not very much different from what we've been doing. We would have completed the involute. We looked at involute, various shapes, triangles and rectangles, squares, circles, and so on. Right? You were given some tasks to complete in relation to all of them. So I hope that you guys would have completed those. Now we'll quickly go through some of the definitions for a parabola, and I'm sure you would have a clear idea as to what it is when we are finished. So basically, it's a U-shaped plane curve where any point is at an equal distance from a fixed point known as the focus, and from a fixed straight line, which is known as the directrix. So keep in mind important words there, right? Focus and directrix. So the fixed point is called a focus, and a fixed line is called the directrix. So when we go into the construction, you'll see exactly what we're talking about. Another definition says that a parabola is a curve where any point is at an equal distance from a fixed point and a fixed straight line. So this is basically saying the same thing that the first definition is saying, right? So the curve where any point on the curve is at an equal distance from the focus or the directrix. Continuing, another definition. A parabola is a plane curve generated by a point moving so that its distance from a fixed point is equal to its distance from a fixed line. Same concept again, just a different explanation, a different wording, right? So those are the definitions or how we can actually say what a parabola is. All right, and here we have some examples. Of course, we can see the shape of it. And here we have some various parts associated with it, right? The axis of symmetry, that's this line here. The focus, which is the fixed point, that's this point here, and the directrix, which is this line. Now, the vortex is this point, and we all know what, or we can associate a vortex with other plane figures as a point where two lines meet. But in this case, is the top or the end point of the parabola. All right, so this is what they basically look like. It's just a curve, a curve shape, like a U. All right, so these are some examples. Now we'll go straight into the construction of a parabola. Today we want to complete two methods of constructing a parabola. Right, the first one would be where you're given the height of the parabola and the span, right, which would be the width. So this is also known as the rectangular method or the rectangle method. So this tells you that we have to start with a rectangle. All right, so without any hesitation, step one is to obtain a rectangle using the height and span. Here we can see the height is 100 mm and the span is 80. So what I'll do, I would use the rectangle option here to obtain that rectangle. But of course, we would have to ensure the rectangle is constructed based on the lengths given, right? Based on the lengths given. What I just want to ensure also is that I find the center. So this here is 78. So I just want to mark the center of that because we need to divide this the span in half. So 68. Good. So we mark the half. Well, for me, I would just mark the half of the span so that I can obtain this line. So what we did, or what I did, is basically divide the rectangle in half vertically, right? Not horizontally, only vertically. Now what we need to do is divide one half into equal parts. And of course, we normally do that by drawing an extra line, using a pair of compasses and scribing your arcs and so on. Right, you would have done that many times. So we mark off equal parts and the amount is not fixed, but we'd use 4. Right, we'd use 4 of them. So we mark off 4 equal parts. Of course, the persons who working on AutoCAD, you would know how to divide your lines. Right? So we divide the line. And this is the traditional way of doing it. And to get the other divisions, of course, we know we have to use our set squares, or one set square and the ruler. So we set it on the line. We use the other ruler. And you slide. It takes a little while, of course, with the traditional method. So I do hope you guys will do this as neat and accurate as possible. So those lines, they have to be parallel, right? We know what parallel lines are. Now, the same divisions that you have here on the first half, we got to do on the second half, right? Which is the right-hand side. But instead of doing all of those again and dividing that part, we can just take the measurement of this point here to the first division, which is there, right? And we bring it across over here. So this is 1, so on. Right, so we have 3 divisions over there also. Now we have to do the same for the height. Right, we have to do the same for the height. So from here, we do the same. We divide this line also, or the side, I should say. Right, so the steps are the same. The length in terms of scribing the arcs, yes, they have to be equal on this line, but you can actually change the length from the one that you would have used at the bottom here. Right, you have to change, you can change the length. There's nothing wrong if you change the length, but you got to use the same amount. If you use 4 at the bottom, you got to use 4 at the side. And of course, we do the same on this side. Right, we do the same on this side. We set the line, set it straight on the line, put the other ruler, the support. And we slide. Right, we try to get these lines as parallel as possible, even though that one that I just draw there, it doesn't look that parallel. Good. And like we did for the base, right, we have to get the same divisions on the other side, on the right-hand side. So we take the measurements from here and we transfer them over to on this side here. Right, 3 of them. So we get 3 divisions on either side. Actually, it's 4, right? But we just have to mark three arcs or draw 3 arcs. Right, so what we need to do next is from this point on top here, we draw lines, each of those divisions at the side. Right, we draw lines to each of the divisions. Good. Now, from the bottom, the divisions at the bottom, we draw lines going up. However, from this one here, we stop at the line that is coming down. So we stop there. Next one, we go to the next line. And then the third one, we go to the third line and stop. Same thing on this side. This one at the end, we go to the first line. This one here, we go to the second. And this one here, we go to the third and stop. Now, right away, we can see that points are established in a particular turn. So this point, this point, this point, and of course, we know the vortex is here. Come around, come around, come around. Now, please note, I am just highlighting these points to you so you can see them. I don't want you to go and put points there. Likewise, there is the bottom point, which is here, and then over here. So that's the starting and ending point. All right, so they are in a particular pattern that would help us now trace the parabola. So starting from the base, of course, it would be difficult for me to get it very straight because, you know, using a mouse, it's a bit complicated. So that's how basically it would look. All right, so that's what your parabola should look like, right? The curve for this particular method using the height and the span or the rectangle method. All right, so that is how the construction is done. Now I will send you some more to do for the practice. I will now go on to the other method, which is using the focus and the direction. All right, now in the definition, these two terms were mentioned, right? The direction is simply a straight line, and the focus is a point on the axis of symmetry. So there is no measurement given for the directrix. So what I'll do is just draw a line. So that would represent the directrix. I'll just mark a point anywhere on this line, probably somewhere at the center. And then I'll use a ruler to get a line which is perpendicular to this one. So I simply draw down that line. Again, there is no specific length for that. Good. Now the focus is given as 60 mm. So that is normally measured from that point there. All right, so 60 would be somewhere here. It's 60 mm. So what we need to do next, and we can just label this point as F. That's the focus. So what we need to do is find the center of that distance, which is it's supposed to be 30 mm, but what we do is just bisect, right? We bisect the distance from the focus to the direction. Good. So when we draw that line through the intersection, that will give us a point now. We label that point V, which is the vertex of the parabola. Now what we do, we mark off some equal points from F coming downwards. All right, we mark off some equal points. So let's reduce that slightly. Good. So 1, and the amount is equal to U. Sorry, is dependent on U. We don't set a particular amount, right? You can see how much space you have and so on, and that will tell you or that would determine how many points you put. So when you finish with that, we simply draw horizontal lines from each one of those points. And the length of those lines, we're not sure as yet what the lengths need to be. And of course, when you want your line to be horizontal or parallel, I should say, you know exactly how to go about doing that, right? The process of getting parallel lines. So we keep doing that for each one of them. When we finish with that now, right? When we finish with that, then we need to take various measurements. Good. So from the point up here on the directrix, we use the length from there. So the first division, we take that length, then we go to F and we mark two arcs. One on this side, one on this side. Now please note, the arc supposed to intersect the line that is coming through this point, right? It's supposed to. However, it didn't, so we need to go and extend the line. All right, we extend the line. So it means that these two would have to be extended also. Right, and also the others. So I'm just extending these lines because of the length that we're working with. But so we do the same. We take the length from number 2 now. So that point on the directrix, and then we place the compass point at F. We're drawing all the arcs from F, which is the focus. Right, so we scribe that there, and then we scribe this one here. Right, then we go again. We come from the third one. So you see, it's just now repeating one step over and over, right? So we do that, then we come from F and we mark the point. Right, we mark the point. Then we go from here, open. All right, so it seems as though this is my maximum. Right, you go to F. come around. Good. So again, as you can see, these arcs that are scribed, they form intersections that if we dot markings there, right, they would give us a particular pattern which would allow us to actually have a smooth curve, right? Well, of course, we know this one is supposed to come out here, and we get a point. This one is supposed to come out more, we get a point, right? So from the base, we plot our parabola, come around, touch the vertex, and go down back, right? And it will be balanced on both sides. What happened? This 60 mm, this bit here, was slightly too much. So I'll just reduce that because it looks a little bit off, right? So I'll reduce that slightly in order to ensure that we don't have this much space here. Right, so this is how it's done basically. So again, I'll prepare a few for you to practice on. And of course, you know the arrangement that we had with you guys doing those homework or those practice exercises, right? You guys know what is at stake. So follow these steps, complete these constructions, and I'll see you guys during the next class.